Let's work through this geometry problem carefully, one step at a time, and pay close attention to how the square and the right triangles are connected. We are given a square WXYZ with an area of 100 square units. Point T lies on side XY, and point U lies on the extension of side ZY beyond point Y. We are also told that segment ZT has a length of 13 units, and the larger triangle ZTU is a right triangle with a right angle at T. Our goal is to find the area of the shaded right triangle YTU. The diagram is not necessarily drawn to scale, so we should rely on the given measurements and geometric relationships, rather than judging the picture visually. Let's start with the square WXYZ. We know that the area of the square is 100 square units. Now, the area formula for a square is side length multiplied by itself, or side squared. So, if we call the side length S, we can write S squared equals 100. To find S, we take the square root of both sides. The square root of S squared is simply S, and the square root of 100 is 10. Therefore, S equals 10. That tells us something very important. Every side of the square has a length of 10 units. In particular, side ZY is 10 units. Let's pause here and notice why this information is useful. We eventually want the area of triangle YTU, and the area of a triangle requires a base and a corresponding height. We can already see that segment YT can serve as the height of triangle YTU, so our next job is to find the length of YT. To do that, let's focus on the smaller right triangle ZTY. Because WXYZ is a square, its adjacent sides are perpendicular. Therefore, side ZY is perpendicular to side YT, which means triangle ZTY is a right triangle with a right angle at Y. We know that ZT is 13 units, and we just found that ZY is 10 units. Let's call the unknown length YT lowercase h, since ZT is opposite the right angle. It is the hypotenuse of triangle ZTY. Now we can use the Pythagorean theorem. Remember, the Pythagorean theorem tells us that in a right triangle, the square of one leg plus the square of the other leg equals the square of the hypotenuse. So here, the two legs are h and 10, while the hypotenuse is 13. Therefore, we write h squared plus 10 squared equals 13 squared. Now let's simplify each square. 10 squared is 100, and 13 squared is 169. So our equation becomes h squared plus 100 equals 169. Next, we want h squared by itself. To do that, subtract 100 from both sides. On the left, the positive 100 and negative 100 cancel each other, leaving h squared. On the right, 169 minus 100 gives 69. Therefore, h squared equals 69. Now take the square root of both sides. The square root of h squared gives h, and the square root of 69 gives square root of 69. So h equals square root of 69. Therefore, we have found the height yt. It is square root of 69 units. Keep that value in mind because we are going to use it again in just a moment. At this point, we know the height of our shaded triangle YTU, but we still do not know its base. The base can be taken as segment YU. So our next task is to determine YU. This is where the larger right triangle ZTU becomes useful. Look carefully at triangle ZTU. We are told that its right angle is at T. Therefore, side ZU is the hypotenuse. Since Y lies on segment ZU, the perpendicular segment YT divides the hypotenuse into two smaller pieces, namely ZY and YU. This gives us a very useful relationship known as the geometric mean theorem, or the Euclidean altitude theorem. The theorem says that when an altitude is drawn from the right angle of a right triangle to its hypotenuse, the square of that altitude equals the product of the two segments created on the hypotenuse. In our problem, the altitude is YT, one part of the hypotenuse is ZY, and the other part is YU. So, we can write YT squared equals ZY multiplied by YU. Now, let's substitute the values we already know. We found that YT equals square root of 69, so YT squared is simply 69. We also know that ZY equals 10. Let's call the unknown length YU x. Therefore, our equation becomes 69 equals 10 multiplied by x. Now we want x by itself, so divide both sides of the equation by 10. On the left, 69 divided by 10 remains 69 divided by 10, and on the right, 10x divided by 10 leaves x. Therefore, x equals 69 divided by 10. In other words, YU is 69 divided by 10 units. We now have both pieces needed for the area calculation. We know the base of triangle YTU is 69 divided by 10, and its height is square root of 69. Before we calculate, let's recall the triangle area formula. The area of any triangle is 1/2 multiplied by the base, multiplied by the corresponding height. So, for triangle YTU, we substitute our base and height. The area equals 1/2 multiplied by 69 divided by 10 multiplied by square root of 69. Now let's simplify this expression carefully. 1/2 multiplied by 69 divided by 10 can be viewed as 69 divided by 20. Therefore, the area becomes 69 multiplied by square root of 69, all divided by 20. So, the exact area is 69 square root of 69 divided by 20 square units. Notice that this exact form is usually the best final answer because it represents the value precisely without rounding. If we want a decimal approximation as well, we can approximate the square root of 69. The square root of 69 is approximately 8.307. Substituting that approximation into our exact expression gives an area of approximately 28.66 square units. So, after working through the square, the smaller right triangle, the Pythagorean theorem, and finally, the Euclidean altitude theorem, we arrive at our answer. The area of the shaded triangle YTU is 69 square root of 69 divided by 20 square units,